Hi guys, good morning. It's another lovely Monday, and today we're going to be having mathematics. But before our class today, I want us to look at a riddle. So try to get the answer. Let's see if you can figure out this brain teaser. So if you're able to get it, you could put in your answer in the comment section. But by the end of the class, anyway, you would know if the answer was right or not. Okay, so this is our question for today. Use the symbols and digits below to form a correct mathematical equation. So can you do that? Try to get a correct equation, and you can only use the digits and the symbols once. You can only use each of the things you can see on your screen. You can only use them once to form a mathematical equation. So like I said, we'll talk about the answer towards the end of the class. So let's move. Okay, so let's take a quick review before we go into today's topic. From the review, you would have an idea what the topic is about. Now, a transversal, when you say a transversal, what's a transversal? Have you ever asked yourself, or have you ever heard about that word transversal? Okay, a transversal is a straight line that crosses two or more straight lines. It's as easy as that. A transversal is a straight line crossing two or more straight lines. Now, these two or more straight lines could be parallel lines, okay, or they could be normal lines, but for our class, we would be sticking with parallel lines. So look at this transversal. AB here is said to be a transversal. It's a line that crosses two other lines, in this case now. So AB, line AB there is said to be a transversal, okay? So that's one of the things I want us to quickly review. And also, you would notice that the lines in black have two arrows on each. One arrow on each, rather. So they have two arrows altogether. And these arrows indicate that these two lines are parallel to each other. When we say lines are parallel, we mean that they are equidistant at all points. That means at every 2 points between those two lines, the distance remains the same. So they are not convergent, they are not coming together, neither are they diverging, they're not going apart. They just remain equidistant from each other. So we call that parallel lines, and we say that parallel lines never meet. Okay, so parallel lines are lines that are equidistant from each other at all points. Okay, so that's something you need to also remember. So let's move on. Now, we talked about this in, I think, 2 classes ago. Yeah, so we talked about how adjacent angles on a straight line sum up to 180. I hope you've not forgotten. If you've forgotten, you can go back and watch angles between lines. Okay, you can go back and watch angles between lines. So adjacent angles on a straight line sum up to 180. So in this case, we know that A plus B is 180. Then we also talked about how vertically opposite angles are equal. Yeah, vertically opposite angles are equal. For example, in this particular case now, we can say that E is equal to F. We can say that angle E is equal to F because E is vertically opposite F. Okay, E is vertically opposite F. And we can also say that C is opposite D. So if C is opposite D, then it means that C and D are vertically opposite. Okay, it means that C and D are vertically opposite. So that's that for vertically opposite angles. Remember that, if, like I said, if you're confused about the topic or you can't remember 1 or 2 things about the topic, you could just go back to angles between lines and just recap on that and come back to this topic. Okay, then we also talked about one of the property. We said angles at a point sum up to 360 degrees. Yeah, so when we say angles at a point, what do we mean? We mean you have some lines that meet at a point, then you have angles formed between those lines. Like in the diagram we have here, we can see that the lines the 2 lines meet at a point, and the angles C, E, D, and F are in between those lines. So we could actually say that C plus D plus E plus F equals to 360 because angles at a point must sum up to 360 degrees. Okay, then let's move on. I think like I said, you could go back and refresh your memory if you have forgotten the topic. But let's move on to today's topic. So what do you need to know in today's class? Okay, what are we even discussing? I know probably that's what you're thinking. I was trying to put you in a little bit of suspense, but some of us will probably have figured it out by now. So what do you need to know in today's class? You need to understand corresponding angles and alternate angles. You need to understand co-interior angles, and you need to be able to determine missing angles on a transversal. So that's why we started with transversal, and we're going to go back there by the end of the class. So you should be able to identify corresponding angles, alternate angles, co-interior angles, and use these properties to determine missing angles on a transversal. Okay, so that's what we're going to look at today. So our topic is angles on a transversal, or you can say angles between parallel lines on a transversal. So because we're going to be focused on parallel lines, okay? So let's talk about corresponding angles first of all. Yeah, let's talk about corresponding angles. Now, corresponding angles are angles situated in similar positions on the transversal. So they have to be in similar positions. They have to be in the exact same positions on the transversal line. On the transversal, they are equal. That's another thing you need to note, that corresponding angles are equal, and they form a peculiar shape, and that shape is the F shape. So they form, when you try to trace these corresponding angles, they form an F shape. Okay, that's their peculiar shape. So let's look at this. So can you tell what angles are corresponding there? Now, there's a saying I usually use. I try my best to give the position of that angle a particular name, and with that name, I use it to determine what angle corresponds to it. For example, for 110 here, let's look at the 110 that's here now. It's on the right side of this transversal. You can see this transversal here that cuts these two parallel lines. It's on the right side of the transversal, and then it's below this parallel line. We have two parallel lines here. It's below this first parallel line, and it's on the right side of this transversal. So I call this 110 here right below. I just use an acronym for it, RB. So right below. And then if I want to figure out what angle corresponds to that, I need to also find out on this parallel line which angle is below and which angle is also on the right of this transversal. So that boils down to this 110 here. Okay, so we can say that the 110 here corresponds to the 110 here because they are both on the right and they are both below. So RB is for 110. And you can see the F shape in red. You can see that it forms an F shape. Just look at the red part of that diagram. You can see that it forms an F shape. Now let's look at the second side. You can see this part of the transversal. You can see 80 degrees here. Now if I want to describe 80 degrees with that same method, I would say that it's on top of this parallel line. It's on top of this parallel line, and it's by the left of this transversal. It's on the left of this particular transversal. So if I want to look for the angle that corresponds to this angle, I would be looking for left above. So that is LA, not Los Angeles, but LA. Yeah, so LA. So this is 80, and if you check this angle here also, it's on the left of this transversal and it's above this parallel line. So we say that these two angles are corresponding. So 80 is LA, left above. So you could decide to adopt this method, or you could come up with something. I just came up with this, so you could always come up with your own method to identify corresponding angles. But if you also notice, these two angles form another F shape, although the F is upside down. But look at the line in blue, you would see that's an upside down F shape. Okay, so like we've said, corresponding angles form a particular shape, and that shape is the F shape. Okay, so let's move on. So let's take one example and let's see which pair of angles in this diagram are corresponding. So can you figure it out? You can pause the video and see if you can figure it out. Just tell me which angle corresponds to which angle, and see if you can get it. But let me move on now and just tell you the answer. But you could pause the video and try it out. So let's look at this. First of all, we can start with the ones that are left above. So left, on the left side of this transversal and above this parallel line, we have B. So that also corresponds to F, because F is above the line CD, is on top of the line CD, and it's on the left of the transversal. So B corresponds to F, left above. Then we could say that left below is D and H. So D corresponds to H because they are both on the left hand side of the transversal and they're below each parallel line. Then we could say that on the right side and above the parallel lines we have A and E, and then we have C and G on the right and below the parallel lines. So you could also use the shape. Remember that you could use the F shape to get your answer. You could use the F shape, try to trace out the F shape, and you would find your answer also. Okay, so that's that for corresponding angles. So I actually love using this because it makes my work easy. I just check, is it on the left side of the transversal? Okay, is it below or above the parallel line? Okay, so I get my description and I move on to the second part of the second parallel line on the that the transversal crosses through. So let's move on. We need to also talk about this, alternate angles. Now, what are alternate angles? What are alternate angles? They're completely different from corresponding angles, although they are also on the transversal. Now, alternate angles are angles that are situated on opposite sides. On opposite sides of a transversal. They are on opposite sides of a transversal. They are equal. They are equal also, and they form a peculiar shape in this case, and that shape is the Z shape, or you can say the Z shape. So that shape is what we often use to identify that, okay, these two angles are alternate angles. Okay, so let's look at how it works. So you can see I've taken the liberty of getting the Z shape already. So you can see that. Look at this one also. So let's start with the first one. The alternate angles here are A and B. So you can see the Z shape. Just pick the angles inside the, the vertices of the Z or of the Z. So pick the angles that are inside where the edges of the Z shape meets. Just pick those angles. They are the alternate angles. So here we have A and here we have B. So A equals B. They are alternate angles. Then the Z shape might not necessarily be the normal Z, the way we write our Z. It could be an inverted Z. It could be an inverted Z. So here we have another inverted Z, but we also know that C here is alternate to D. C is alternate to D, so we say C equals to D, or C is equal to D. So those are the two cases where we'll just consider for alternate angles. So you just need to look out for a Z. Look out for a Z when you're trying to find alternate angles. Sometimes as you advance in mathematics, sometimes the diagram will not be complete. Sometimes you would have to indicate probably a line to actually trace out that Z shape. Okay, but for now I want you to just focus on understanding this and be able to trace your Z for alternate angles. So I want you to look at some examples. Which pairs of angles are alternate? Which pairs of angles are alternate? So you could pause the video and you could try to get it, but I'm going to do it now. So let's start with this. I've traced out the Z there. You can see the Z there. So which angles are inside, or are the vertices of the Z shape? Okay, we can see D here, right? We can see D inside the Z here and E inside the Z at this edge of the Z. So we can say automatically that D is equal to E. They are alternate pairs. They are alternate pairs. Then let's get rid of that particular Z and let's see if we can trace another Z. This time an inverted Z. So look at this. Can you see that? So here we have an inverted Z, and C here is inside the vertex, and F here is also inside here. So we can also say that C equals F. We can also say that C equals F. So that is another alternate pair. So like I said, you need to get familiar with tracing the pairs. To get the pairs, you need to get familiar with tracing the Z. So once you're able to trace the Z, look at the angles inside. Should I say the crevices, or let's just stick with vertices? So we'll look at the angles inside the vertices of that Z, and then we say, oh, those angles are the alternate angles. Okay, it's fun and it's very easy. As you practice and do more on the topic, you would get it completely. So remember to always practice. Okay, all right, let's move on to co-interior angles. Now, co-interior angles are angles that lie between two lines and are on the same side of the transversal. Now, they're not opposite like the alternate angles. They are not opposite like the alternate angles. They lie on the same side of the transversal, but they are between two different lines. They're between two lines, and they are not equal. They are supplementary. When we say two angles are supplementary, we mean that they sum up to 180 degrees. Okay, when you hear that word, in case you don't know or you've forgotten, supplementary means they add up to 180 degrees. So let's take a look at the diagrams here. So look at A and B in these cases. These two cases, you know, A and B, they are not opposite. They are on the same side of the transversal and they lie between two lines. So this angle A is called the co-interior angle of B, and the same thing applies to, you know, we got this from the fact that angles on a straight line will be 180, right? We got that from that fact that angles on a straight line will be 180. So if we know that angles on a straight line are 180, then automatically this angle A corresponds, this angle here corresponds to this angle here, right? Remember corresponding angles? Yeah. So by the time we just assume that we know, okay, we're not assuming because it's true, this angle corresponds to this angle. It means this is also A. So that means that A actually sums up with B to 180. So A and B are supplementary angles, co-interior angles. Okay, so that's a plus. That's a plus for today. That's a plus. So A plus B equals 180 degrees. A plus B equals 180 degrees. So let's go to the example number 3. Find all the marked angles. Find all the marked angles. We want to find all the angles that are on this transversal between these two parallel lines. Now we want to get every angle. We only have one angle, and you're probably thinking, okay, how is that going to work? How can you have just one? Because in mathematics we often say that when you have an equation for when you have two unknowns in an equation, you should have two different equations to solve that question, or that if you have an equation, just one equation, and then you have probably 4 different values, 4 different variables, for you to get one unknown variable, it's said that you need 3 variables, right? I know some of you are already thinking that direction, like you just have 70 degrees and you're asking me to get A, B, C, D, E, F, G. Okay, am I supposed to work some miracles here? But it's not difficult. So by the time we get into it, you see how easy this is. So let's start. Now, first of all, let's talk about how A and 70 are on a straight line. Let's talk about that first. Let's talk about that. Remember, that's what I have said. If you do not remember the last class, 2 classes ago, we talked about angles between lines. I did a quick review of that, but if you are still confused about that, you could go back to the that class and that video and watch. But let's talk about how A and 70 are adjacent angles on a straight line. The adjacent angles on a straight line. So A plus 70 equals to 180. Now what that simply means is that A is 180 minus 70, right? You take 70 to the other side, it becomes negative, and then A becomes 110. A is 110. Okay, now the next thing we need to understand is that B is vertically opposite A. If you see that B and A are vertically opposite from our previous classes, you would be able to say assuredly that B is 110 degrees. Okay, the next thing we need to know is that C is vertically opposite 70. Can you see we're breaking it down little by little? C is opposite 70. So C is vertically opposite 70, so C equals to 70. Then we can come down to D. Now, D is on the left side of the transversal. This red transversal is in red. It's on the left side of the transversal and it's above this line. So it's corresponding to 70 degrees, which is also on the left and which is also above this line. So D is 70 degrees. Now, if we've been able to get D as 70 degrees, then we can also say that E and B are alternate angles. They form a Z shape. If you check it very well, you see the Z, okay? They form a Z. So B and E are alternates. B and E are alternates. So E is 110. You could also use corresponding angles for E anyway. You could say E is corresponding to A, and that would also give you 110. Okay, so you can see it's lovely. There are so many ways to find the solution, so it's very easy. Then we could say that F is corresponding to B. They are at the exact same position on the left side of the transversal below the parallel line. So F is also equal to B, and that gives us 110. Or you could have said F is vertically opposite E. So you can see there's so many ways you could probably solve this question. Then the last one is G, and I decided to go with G is corresponding to C. Okay, G is corresponding to C, because they're at the exact position on the two parallel lines. So G is equal to C. That means G is 70 degrees. You could also go with G is vertically opposite D, right? G is vertically opposite D, which would also give you 70 as well. Okay, so let's go on and let's summarize, the concepts that we've looked at today. So first of all, we have said that corresponding angles form an F shape and they are equal. Now we talked about how corresponding angles are angles that occur at the exact same position. Okay, so if one is on the left side of the transversal and below the parallel line, the other must be on the left side of the transversal and also below the parallel line, not something else. Okay, so that's what we said about corresponding angles. Remember that they are equal. For alternate angles, we said they are on opposite sides of the transversal and they form a Z shape, and they are also equal. So you should be looking out for that Z when you're trying to get alternate angles. Okay, if you have two parallel lines and you have a transversal, there will surely be corresponding angles and there will surely be alternate angles. Now all that's left for you is to be able to identify which one is corresponding and which one is alternate. Okay, so co-interior angles, we also talked about that. We said from our knowledge of angles on a straight line, we saw two angles around a straight line, and then we said, okay, one of the angles corresponds to this other angle, and from there we derived that co-interior angles sum up to 180 degrees. So they are supplementary. That's the last thing, the last, should I say, rule that we talked about before we went into examples. Okay, so that's simple. So like I always say, it's very good that you practice. It's very good that you don't just watch the video, but you actually sit down at home and you practice what you have learned. Okay, so our answer to this particular question, for those of us that might have tried to attempt, might have attempted this, the answer here is 4 plus 5 equals to 3 raised to the power of 2. 4 plus 5 is 9, and 3 raised to the power of 2 means 3 times 3, so that's also 9. So 9 equals to 9, and that's our answer. Okay, so like I've always said, these questions that you have seen, these examples that you have seen, they're not necessarily enough to establish or solidify the knowledge of this topic in your brain. So I need you to try to practice, even apart from this question. Although I'm giving you one question here to fill in the missing angles. The lines in black are parallel. You could just, when you're drawing out yours, you could put an arrow. You need to actually draw the diagram and try to represent it on your own paper. So you could just put your make sure you indicate that the lines are parallel when you're solving it, then fill in all the missing angles. So practice, even apart from this question that I'm going to give you, practice all the questions. So you could visit quizzes.com and try to get some questions on angles. Okay, so I want you to do your best to always put in that extra effort. If you really want to, do well in mathematics and you want to, love mathematics, you just need to practice, okay? So I'll see you guys again next Monday. It has been lovely taking you guys today. I hope you continue to have a lovely day. Don't forget to subscribe. You could like the video, share to your friends, and just take care of yourselves. Bye-bye. Hi, guys.